Hello guys, welcome back to my channel, Ekene Canada Knowledge Quest. Here we do justice to mathematics, engineering, and general knowledge concepts. Today we're going to continue on what we started earlier, indices. Earlier we were able to talk about the concept of indices, the fundamental laws of indices, and derived laws of indices. If you haven't watched it, please subscribe to my channel, go back and watch the previous video. Now we're going to continue on how we can use those laws to solve some basic problems in indices. So these are some of the questions we have here. We're going to use some of those 7 laws to solve these questions. So you can see we have 10 questions here. To solve the first one, you can see is 216 into 2 over 3. You will call the fractional index. So when we have something like this, you remember from the 6th law, you first of all put your root sign here. What is below the index? Then this fraction is 2 over 3. Remember, it's called the fractional index. Now, this is the index here. What is below the index? We put it at the root sign. Then, what is the base? We put it inside the root sign. Then, the what is on top of the fraction, we raise it to the power of 2. Now, how can we get the cube root of 216? Now, to solve this, to get the cube root of this, we'll do something we call prime factorization. So let's see and say 216. How do we know if 2 can divide it? If the last number here from our previous video, rules of divisibility, if the last number here is either 2 even numbers or 0. If it is an even number, and say 2 here, 2 in 2, 1, 2 in 1 cannot go 0. Put the 1 here, 2 in 16, 8. This is still an even number. You can use 2 again. 2. 2 in 10 is what? 5. 2 in 8 is what? 4. Still an even number. You can use 2. 2 in 5. 2 remainder what? 1. 2 in 14 is what? 7. Now, is it an even number? No. Does it end in 0? No. Now, what are the rules for 3? 7 plus 2 is what? 9. Can 9 divide 3? Yes, because remember in the rule 3, or rule of 3, if the sum of the digits make up a number that can divide 3, we know that 3 can divide it. So 7 plus 2 makes up 9, and 3 can go in 9. So say 3 in 27 is 9, 3 in 9 is what? 3, 3 in 3 is what? 1. So this is the factorization, 2 and 3. How many places is 2? 2 into 3 times what? 3 into what? 3. So it's factorized. So what does this mean is that we have, this is 2 into 3 times 3 into what? 3, and 6 into what? 3. Because 2 times 3, remember the law of this, the multiplication law. When we have the same indexes, we take 1 and multiply the base. 2 times 3, 6. So what this means that the cube root of what? 216 is what? 6. So that is what this calculation means if you are confused about how to get the cube root. So we have this, the cube root of 216 is what? 6 into what? Squared. And what is 6 squared? Is what? 36. So that is the first one. You can pause the video here and try others to see if you are correct before we solve it. To solve the second one, the number 2, we have minus 41 raised to power 0. You remember our fourth law of indices, the zero power law. Any number raised to power 0 is what? 1. And we're able to prove it. So this one is very simple. We move to the third one. The third one is what? 0.008 raised to power minus 1 over 3. How do we solve this kind of thing? Remember, this is a fractional index because the index is in fraction form. So what do we do? But first of all, we have this as a decimal number. We have to convert it to what? A fraction. And what do? You can see after the point, we begin to count the decimal places. You say this is 1, 2, 3. And 1 is equals to what? 10. 2 is equals to what? 100. 3 is equals to what? 1000. For the basics, for people who don't know how to. So when we count this on the decimal point, we count 1, this is 10, 2, 100, 3, 1000. So we'll now take the 8 over 1000. Then raise to power 1 over 3. Now what do we do next? We can express these numbers in index form or indices form. So we know 8 is what? 2 times 2 times what? 2. If you don't know it, you can do the prime factorization we did earlier, where you can say 8, 2, just like that. Over 1000 is what? 10 times 10 times what? 10 raised to power what? 1 over 3. Now, what do we do next? Remember, from our basics law of indices, if we have a raised to power m, it means that a must be raised to the power of m times. So in the same way, this is 2. How many places do we have 2? 1, 2, 3. So we have it in 3 places. Over 10. How many places do we have 10? The same 1, 2, 3. Everything is still is power of minus 1 over 3. Now, what do we do next? You remember from our second law of indices, when we have the same power, not the second law, but from our, I think the fifth law, is the multiplication or the division, the power law, the product law. We have the same power, but different bases. So we can take 1 and divide. 2 divided by 10 is what? 1 over 5. So we can just take one index, which is what? 3. Then everything is still to the power of what? Minus 1 over 3. Are you following? Because 2 can divide 10, we have 1 over 5. Since the powers are the same, we take one power. Now, from the third law of indices, which is the product law, when we have something like this, a raised to power m times n, what we do, we just multiply the indexes, which is equal to what? A, m, n. We're going to apply that same law here. So what do we do? This can multiply this, because this is the numerator, this is the denominator. 3 can go. So we have, what do we have left? We have 1 over 5 raised to power minus 1. Now, you remember our negative index law, which is the what? The fifth law. Anything, when we have this something like this, we to be said 1 over 1 over 5. Now, if we have 1 over 1 over 5, let's take it here to complete. If we have something like this, 1 divided by 1 over 5, we can say complete this 1 over 1. So what do? We say 1 times 5 over 1. We change the sign and then we invert. So what will be the answer? Answer will be 5. So that is that for the number 3. We'll go to the number 4. We have minus 8 into power of 1 over 3. If you are still watching this video till now, it means you are actually enjoying what we are doing here. Do not forget to subscribe, like, follow us for all our pages, share to your friends so they can also come and learn mathematics. So how do we solve this one? Now, to solve this one, it's very simple. We just say this is what? Minus 8 is what? Minus 2 raised to power what? 3. Because 8, the cube root of 8 is what? 2, which is minus 2 times minus 2 times minus 2. Minus 2 times minus 2 is plus 4. Plus 4 times minus 2 is what? Minus 8. So into 1 over 3. So basically, like we did previously, we can just cancel the using the power law. So we have what? Minus 2. So that's the answer for that. So move to the next question. Number 5, we have 3a7 times 5a0 times 2a minus 6. So how do we solve something like this? It's very simple. Just apply the laws again. So what we can first of all say, we can take out the numbers 3 times 5 times 2, times, then the variables can say a7 times a0 times a raised power minus 6, So multiplying the numbers, the integers first, 3 times 5 is what? 15. 15 times 2 is what? 30. This raised power 0 is 1 times a raised power minus 6 times a raised power 7 times, because a raised power 0 is 1, remember from our law. Then this has the same base. What do we do? And they are multiplying the first law of indices. We add the power. So we have 30 times a 7 plus minus 6. They have the same base, so we add the power 7 plus, then put in brackets minus 6. Whenever you introduce a minus sign into something like this, you have to put it in bracket so that it doesn't confuse you. We have 30a plus times minus is minus. 7 minus 6 is 1. So you can just say, if it's raised to power 1, you can just say 30a. So that is that. Very simple. We go on the number 6. We have 6d minus 3 times 6, 3 minus d. So this one too is very simple. As I told you, these are the simple ones. Subsequently, we're going to move to some more complex or more tricky questions, So they have the same base and they are multiplying. What do? We add the powers from the first law, remember? So this is 6. We take 1, add the powers, d minus 3 plus 3 minus d. And now we 6. D minus D is what? It cancels 0. Minus 3 plus 3 is 0. I have 3 naira and I'm owing 3 naira. I'm not going to be owing, I don't have again. So it will be what? Everything will be 0. And 6 raised to power 0 is 1. From the fourth law of indices, remember. 7. I have 32 H11 divided by 8H4. Now, you can see it's still very simple again. We basically have the same base. We're looking at the variable, basically have the same base. You divide and subtract the powers. How do we do it? You can say 32 over 8 from the quotient law, remember. Then you say h h into what? 11 minus 4. So 32 divided by 4 is what? 4h raised to power 4. Sorry, 11 minus 4, it's 7, no? Three d minus 1 into half times 3d 5 into 3 over 2. To solve something like this, first of all, what we do is we isolate this one and isolate this one. Now, isolating this one, we can, first of all, from the law of indices, you can see this one, this index covers both 3 and the variable. We're going to separate them individually. So that will be 3 times raised to the power half times d minus 1 times what? Half, and close this bracket, times what? Open another bracket, 3 over 2 times d 5 times 3 over 2. So this, you can still leave it like this. 3 half times d, can multiply this, which is minus half, times 3 into 3 over 2 times d into what? 5 times 3 is 15 over 2, So what can we do next? The same base multiplying, we add the powers. The same base multiplying, we add the powers. Now, this is what? 3, collecting the integers first. 3, the same base, we add the powers, which is half plus 3 over 2 times, take the variable, this time they're the same base, and they're multiplying, that is d into what? Minus half plus, add the powers, because they are multiplying on the same base, 15 over 2. Now, 3, they have the same, they will take LCM, which is LCM of 2 and 2 is what? 2. 2 into 2 divided by 2 is 1. 1 times 1 is 1, plus 2 divided by 2 is 1, times 3 is 3, times, we take, for this one, D, take LCM. LCM of 2 and 2, remember, is 2. 2 into 1 times minus 1, minus 1, plus 2 into 1 times 15, 15. So 3 plus 1 is 4. So 4 divided by 2 is what? 4 over 2 times D. 15 minus 1 is 14 over 2. So we have 4 divided by 2 is 3, 2 times D, 7. And what is 3D? 3 raised to power 2 is what? 3 times 3 times D, 7. So final answer is what? 3 times 3 is what? 9D raised to power 7. So see, you can see it looks complex, but it's very simple. Just follow the procedures and the laws and you're going to get your answer. So we're going to solve the number 9 is 10 a raised to power 5 times 4a raised to power 3 divided by 8a raised to power minus 2. So how can we solve this? It's still very, very simple. First of all, we can take the numerator first, because can say 10 times 4 is 40. Then they have the same base. Looking at the variable, most of the time you look at the variables when you're taking those laws. They have the same base and they are multiplying. So to be a, add the powers, 5 plus 3 is what? 8 divided by 8. Now, this negative index now, it affects only the a. Assuming we have this bracket here, it's going to affect both the 8 and the variable, which is a. But now we don't have a bracket here. The negative index only concerns the a. So we say, and when we have something like this, we have it will be 1 over You can say over A. Now make this over A again. Over A squared. Because if we have x raised to power minus n, it will be what? 1 over x n. So this is the same thing as saying times 1 over A squared. Now, what can we do now? We have 40A8 over 8. Now, this one will come and meet this one on top. That will be times A2. Why? Because as I've shown before, when it's divided, it goes up again. So 8 here 1, 8 here 5, A8 times A2. I've said repeatedly, most of the time the law appears affects the variable most times. Then A, the same base, add the power, 8 plus 2, 10. Now for the last question, we have 24x4 y squared 1 over 3 divided by 3xy squared 1 over 3. This is our last question for today. Okay, for our last question, we have this. It's very simple too. Basically, you can see they have the same power. So we just divide and take one power. So we have 24x raised to power 4 y squared. This divide is same as this 3x y squared. Then you can just take one power, So we can divide, as I always said, the laws basically sometimes mostly affect the variable. So we can just divide here straight. This is 3 here, 1, 3 is here is 8, half 8. We can put a 1 here because any number we have is same thing as this power 1, or 1 times that number is still the same number. So from the quotient law, when we have the same base, we can subtract, which is x raised to power 4 minus 1. Now this is y, 2 minus 2 is 0. So anything is power 0 is 1, into 1 over 3. You know how we got this one here? This is y into 2 minus 2, which is y0, which is anything is power 0 is what? 1, from our law of indices. So we have 8x3 times 1 into 1 over 3. As I explained earlier, this power here affects both this and this. So we can say 8 into 1 over 3 times x3 into times 1 over 3. So we can multiply this, this can cancel out. We have 8 into 1 over 3 multiplied by x into 1. What is the cube root of 8? And say 8 cube root 1 times what? X. What is the cube root of 8? Is what? 2 times x. So our final answer is what? 2x. Thank you guys for watching. Do not forget to subscribe to my channel, like, comment, share to your friends, so that they can come and join our page and enjoy the things we're doing here. Thank you. Bye.